My name is Alexander, and I work at AWS. I'm based in Stockholm, Sweden, but originally I'm from St. Petersburg, from Russia. Live in Sweden for last 12 years, and yeah, with AWS for last 2 years, making .NET great on AWS and Microsoft workloads great on AWS. So that's my areas of expertise. And today I'm going to talk about AWS Lambda. So uh, I will start with kind of high-level overview and then like go deeper and deeper with each slide. So probably if you have some questions in the beginning, just keep them until the end because probably they will be answered during my talk. But if not, feel free to ask them at the end and I will try to cover them. So first, what is AWS Lambda? And if we start with very high level view, and many people actually start here and they stop here, not will not do it. So it starts with some kind of event. And when you write your Lambda function code, and we have number of supported runtimes, supported languages such as Python, JavaScript, Java, C#, Go, but also you can bring your own languages using custom runtimes. And less than a year ago, we introduced support for container images, so you can package your Lambda functions using container images. And on the other side, you have different AWS services which you can interact from within your Lambda function, different databases, services, or anything you want, basically. So if we go next, look at the pricing view. So there are simply two main pricing components. So one is number of requests served by the Lambda function, and the second component is duration. And the duration is metered in gigabyte seconds in 1 millisecond increment. And again, this 1 millisecond increment, it's something which we introduced less than a year ago. So what this gigabyte second means, it means that, for example, if you have Lambda function with 2 gigabytes of memory, which runs for 100 milliseconds, it will cost you the same as if you have a function which has 1 gigabyte of memory, which runs twice longer, 200 milliseconds. And talking about this 1 millisecond duration, the important thing here that it's before that it was measured by 100 milliseconds. So duration was rounded to the nearest 100 milliseconds. But now it's 1 millisecond, and it's good for use cases where latency is really important. So if you have functions which takes like few milliseconds, then you will benefit from it. But if you have functions which are running, I don't know, several seconds or even several minutes, and you will not benefit from this. Okay, so if we go even deeper from customer perspective, so Lambda actually it's pretty complex service. So there is a lot of options and configuration that you can alter. So here is your function code, and there is a different ways to package it, and I will talk about it later. But also there is an execution role, so what Lambda can do, what services with Lambda can access. When we have Lambda permissions or IAM, so who can call this Lambda function. Then functions can have different versions, and functions can have different aliases, and then you can do blue-green deployments, canary deployments with Lambda. So there is a lot of moving pieces which you can configure. But if we zoom in into the code part, there are two packaging mechanisms for Lambda. So historical one is using zip files. So most customers, they just provide function code, and then it's running on top of Amazon Linux or Amazon Linux 2. And optionally, you can have Lambda layers. And nowadays, we also have container images as a packaging mechanisms, which we introduced less than a year ago, and I will go a bit deeper into what's the difference. And also here I want to mention one important thing, that container images is a packaging mechanism for Lambda function. So Lambda does not run containers. So container image is a packaging mechanism. It's quite important to note here. Okay, so now let's dive even deeper under the hood. So on the left, it's a kind of invocation path. And on the right, we have workers. And actually, workers, these are just EC2 instances, which are running a number of micro VMs and different execution environments. They are isolated using micro VMs. And we will talk about all these pieces in the next slides. So first about Lambda invocation modes. So there are 3 invocation modes which Lambda support. So you can call Lambda functions synchronously, you can call synchronously, and you can use event source mapping. And all these 3 invocation modes, they work in a slightly different way, and I will show the differences. And this front end, I mean, I called it front end, but basically this is the API which Lambda has, and then different invocation modes interact with Lambda. Okay, so synchronous invocation mode, it's used when you need direct response from a function. So function is executed immediately, and a good example here could be API gateway. So you have your API and you want to receive response as long as function executed. So asynchronous is when you don't expect response from a function, you just receive acknowledge, okay, I received your request, that's it. And a good example of asynchronous invocation could be SNS notification. And the last invocation mode is event source mapping. So it's integration with different event sources. So it could be DynamoDB, it could be Kinesis, and it's actually synchronous under the hood. And I will talk about it when we talk about event source mapping. So first, synchronous invocation mode, and this is usually the one you start with. So again, we go from left to right. So there is an event, then there is a Lambda API, and then it calls the Lambda function code in execution environment. And you use this synchronous invocation mode when you need immediate response from a function. And also you need, because you are waiting for a response from a function, errors are also returned to the caller. And also when you hit your Lambda quite heavily, then you will be throttled when you hit the concurrency limit. So it's synchronous, there is no intermediate buffer, so you will get throttle errors. So with asynchronous invocation, when you call a function, you only get acknowledgement that, okay, we received your call, we will proceed it. And then there is an internal queue which can persist with requests for up to 6 hours. And also, if there is a kind of error in execution of your function, then it will be retried. And you can use Lambda destinations or dead letter queue to put the messages which we were not able to proceed. And also, like asynchronous functions, the benefit here is in terms of scaling, because this internal queue, it acts as a buffer. So you will not hit this concurrency limits, and you will not get throttled because your calls will be buffered. And the last way to invoke functions and using event source mapping. So what how it works. So event source mapping is a kind of component that pulls messages from different sources, and the sources could be, I don't know, DynamoDB, Kinesis, and based on, I mean, the implementation is based on this event source. So like in Kinesis, it will be one, in DynamoDB, it will be a bit different, but you can do batching here, where you can do error handling, but the capabilities will be differ by the event source that you use. So in a short summary, like this is the quick overview with some examples on synchronous, asynchronous, and event source mapping. So synchronous, I don't know, the good example here would be API gateway, where you just wait for response from your Lambda function. Asynchronous good example could be SNS, when you just send notification using to Lambda, and you don't need any response if happen this notification. And then event source mapping, so it could be a simple queue service, so DynamoDB or Kinesis or Amazon MQ, for example. Okay, so now let's go even deeper into the Lambda execution environment. So this is right part of this diagram. So execution environment is where your code actually runs, and there is only one execution environment proceeds one request at a time. And when we talk about execution environments, we always also talk about concurrency. So concurrency, it's a number of execution environments which are serving traffic for a given period of time. And we will talk about concurrency control in a few minutes. So this is execution environment lifecycle. So if we go from left to right, so if we start with initialization, or also it's called cold start. So this is where your code is downloaded, your execution environment is allocated, runtime is started, your own initialization code is run, and then the function becomes warm. So this is where the code is executed. And then in the same execution environment, you can have a number of invocations of function. And you can have another execution environment, and again, you get this initialization and then number of invocations of a function. But again, like one environment has executing one function at a time. So now, like how this runtime architecture looks like and what are the components inside this execution environment. So first, you have various software components for your operating system. So it will be your operating system and operating system packages. Then you will have your language runtime, such as Python or Node or Java. Then you have your code which you wrote for initialization and for actual Lambda handler. And then there is something called runtime interface client. So what it does, it interacts with runtime API to retrieve events from a Lambda service. So runtime interface client, it asks for next event from runtime API, and it proceeds with event. And once it receives this event, it invokes the appropriate runtime interface client, invokes the initialization code for the function and the actual function handler. So when you package your Lambda function as a zip file, and this was the only approach until end of last year, you only provide this initialization and handler code, and everything else is provided by AWS. But we introduced this container image support, so we provide base images for all supported language runtimes. So still you can use the container image which is provided by us. You will deploy it, but you will only provide your code on top of this container image. But also, we open sourced Lambda runtime interface clients for all of our supported language runtimes. So actually, you can provide your own Linux-based operating system with language runtime, with your own code, but just use the runtime interface client library on top of your image to interact with runtime API. Or ultimately, if you really need to do it, I mean, you can implement your own runtime interface client, which talks to runtime API. So, and you deploy the whole container image with all the components from operating system to Lambda initialization code and handler code. But what I want to mention here is that if you provide only function code, then you're responsible for function code, and AWS will be responsible for patching of operating system, updating to the latest language runtime, etc. But if you provide your container image based on our base image or based on your image, then it's your responsibility to patch this operating system with latest runtime and latest operating system components. So it becomes your responsibility. So you need to do it. So this is a timing diagram which shows how different components interact. So after Lambda calls runtime API with some event, then runtime API calls runtime to do the initialization. Once the installation is done, runtime calls runtime API to get the event. It gets the event, it runs the function handler with specific event, returns response to the caller, and then asks for next event. And in case if there is no next event for this runtime, it becomes like frozen. So it doesn't consume like CPU cycles. You are not built for it. And then once there is a next event, it like defreezes, runs the handler, returns response, and the story continues. So, and the last thing about execution, which I want to talk about execution environment, is its size. So in Lambda, you have like only one control of execution environment, its amount of memory. And you can configure it from 128 megabytes to 10 gigabytes. But one thing to mention here that the more memory you have, the more CPU resources you have. So this 128 megabyte function will have like one vCPU, but the biggest function will have 6 vCPUs. So the more memory you allocate, the more vCPUs you have. And then for each kind of function, there is like a sweet spot when you like pay less for based on the size and duration of your function, and there is a tool you can use to try to find this sweet spot. And also, because the bigger the function you have, the more vCPUs you have, please consider using multi-threading. So assume that you have more than one vCPU and write your code to utilize multi-threading to get the benefit of having multiple vCPUs. Okay, now that's it on execution environments. So now let's talk about scaling and things you need to keep in mind when scaling of Lambda function happens. So first, a bit about terminology, not to mess up like concurrency, duration, and throughput. So there is a concurrency. So concurrency is a number of execution environments which serves functions at the same time. And the throughput is number of requests per second. So if your function is takes 1/10 of a second to execute, and you have 100 concurrency, then this means that you can your throughput is 1,000 requests per second. Okay, So some quotas which you need to keep in mind. So concurrency. So it's a concurrency for given region across all your function. And this quota can be increased actually. So by default, it's 1,000, but it can be increased to tens of thousands if you create support ticket. And when there is a burst concurrency, so it's a maximum increase in concurrency for initial burst of traffic. So this is where we are talking about spiky workloads, like I know how to scale from 0 to 5,000. And it depends on the region. So this burst concurrency is 3,000 in the biggest regions in Oregon, North Virginia, and Ireland, when it's 1,000 in Tokyo, Frankfurt, and Ohio, and 500 in all other regions. And once you reach this limit, then the functions will scale by 500 concurrency per minute. And it's better to show it on a graph. So imagine you have this. So this is axis is when y-axis is a number of execution environments. So your function and the number of execution environments is scaled until the burst limit. So for example, 3,000 in Ireland, but our concurrency limit is 5,000. So here you see that we scale 500 per minute. So we're adding 500 per minute, 500 per minute until we reach the concurrency limit. And the striped region here is where you can have throttle exceptions. So if you need more functions, if you want to run more functions, you need more execution environments, we will not be able to scale faster than this 500 per minute. So you will be throttled here. And in order to control it, again, we introduced a feature called provisioned concurrency. So you can pre-warm execution environments to first to reduce cold starts, because this the initialization will already be done, and then your function it will not be throttled until it reaches this provision concurrency. So again, this is how many so this is your function, how it's executed, how many execution environments it needs. So first we initially burst until the burst limit, and then we scale up until the provision concurrency, but you will not be throttled here. And also you pay for this provision concurrency for gigabytes per second, and execution for under this provision concurrency limit is cheaper than on demand. So if you heavily utilize provision concurrency, like in summary, you can save some money. Okay, so next control is reserved concurrency. So you can allocate maximum concurrency for a given function, so that this function will not be throttled, for example. So and it will so when you reserve concurrency for specific function, no other function can use that concurrency. So for example, you want your authentication API like to be not to be throttled, and so yeah, you can use this reserved concurrency feature, and there is no charge for reserved concurrency configuration. Other features which I want to mention, first, it's mount EFS file system to your Lambda function, and it will be visible just as a local directory. So this means that you can share data in between functions or other resources like EC2 instances. They can access it at the same time. Then you can use the feature called code signing, so you can be sure that only code signed with specific key can run. So Lambda will check every code deployment and verify that the code package trusted. And the last feature I want to mention is RDS proxy. So if your function is talking to a database, then you can throttle actually database connections. So RDS proxy is a pool of database connections to be able to reach high concurrency without throttling database. And the last feature which I want to mention is, I don't know if you heard about our Graviton 2 processors, but this is our ARM-based CPUs, which are developed by AWS, and you get better performance at lower cost, but it's ARM-based architecture. And for Lambda, it was, I think, like 2 weeks ago, we introduced support of Lambda functions which can run on AWS Graviton 2 processors. So when you create your Lambda function, you just specify that, okay, instead of x86 architecture, I want to use ARM architecture, and that's always needed from your side. So if you can use it, just use this feature because you will pay up to 35% less, or like your price performance will be up to 35% better. Okay, some quotas which I already mentioned, but I want to emphasize them again. So concurrent executions. So by default, it's 1,000, but it can be increased to tens of thousands. Burst capacity limit, which I mentioned, it's a hard limit based on the region. For the payloads, again, these are hard limits, so 6 megabytes for synchronous functions and 256 kilobytes for asynchronous. For deployment package size, and this is where you can benefit from container images. So when you use the zip files, before we introduced support for container images, you had to be quite smart about how you do it, how you package your functions not to exceed this limit. But with container images, it's up to 10 gigabytes, so you can store artifacts which are required for this function inside container image. Then there is a temporary storage which your function can use, and also number of invocations per second. It's limited, so 10 times of concurrent execution quota for synchronous functions and nearly unlimited for asynchronous functions, again, because we have this buffer. And some best practices, which I want to mention and finish my talk. So you come with this knowledge. So first, error handling, as you all know, it's very important. And for synchronous functions, it's up to you how to handle the errors, because function just returns an error to the caller. But with asynchronous functions, you need to configure destination on a function to store the failures so you can analyze them. So for example, for simple queue service, you can use dead letter queue, and for other event source mappings, there is a way for you to configure destination to store the failures. And the last is about cold starts, like how you can optimize it. So there are two parts in a cold start. So there is a full cold start when your function code or your container image is downloaded, when new execution environment is created, and this is where we do optimization. But then it's your code with your initialization and your handler code, and this is where you do the optimization. And cold starts, they happen quite often in development because you don't have like that many functions running concurrently. But in production, it's quite small percent of the traffic. But still, it happens when you update the code, when the function is scaled, when new execution environment is created, when rebalancing happens, when something fails. And you can improve cold start. So you can reduce package size by creating single purpose Lambda function. So don't create generic packages with multiple functions, create single purpose functions. Optimize like what you import, do lazy loading instead of doing all initialization at once. Optimize the code, If you want to reduce the likelihood of hitting cold Lambda functions, you can use provisioned concurrency, and also take advantage of that you can reuse execution environment by doing initialization outside of function handler. So for example, in C#, if you use static variables, I mean, this data will be stored like in between executions. So keep it in mind. Okay, so that's all which I wanted to cover in this half an hour about Lambda functions. So I hope now you have some kind of more structured knowledge on how it works under the hood, what are the different execution modes, how execution environment looks like. So if there are any questions, I will be happy to answer.
So thank you so much, Alexander, for this presentation and for giving this basically dive into the lambdas and world of the serverless. And I remember when I first had experience with Lambda more than 3 years ago, it was like really, really, really basic. It didn't have all these advanced features which we have right now. But I should still remind everyone that doing serverless and going serverless require some particular mindset, and this is a much more granular environment, and it requires definitely more responsibility of the developers. For example, from my perspective, I remember that when we created first POC, as I mentioned in the very beginning, we thought that execution of our Lambda were hitting like 2.5 seconds. So, and since you're paying for this time plus resources, we decided to optimize it. And after some few rounds, we reduced execution for less than a second, and that was amazing because we optimized in 2.5 times, meaning that we immediately got this benefit of the saving resources, saving money basically on execution. So, and yes, and getting back to the question, can we the first question is which infrastructure of the code approach would you prefer for your next project, serverless or Terraform? So would love to hear your thoughts before I share mine.
Okay, so actually, I am a big fan of CDK. So this is Cloud Development Kit. And so this is where so in Terraform, you define your infrastructure in domain-specific language. So again, it's something that you need to learn or to master it. But with CDK, you can define your infrastructure using ordinary programming languages such as C#, Java, TypeScript, JavaScript, Python. So you just write your code, and under the hood, CDK will generate CloudFormation template for you and use CloudFormation engine to provision the infrastructure. But the code will be very easy to read, easy to understand, because we provide same default values, so you can start very easily with different services, and then if you need to tune them, you will add like more parameters, configure it further down the way. But I'm like big CDK fan, so if you haven't tried it yet, I encourage you to give it a try because it's a great way to work with infrastructure.
Right. I don't want to start holy war here because it's been a lot of conversations and comparison between CloudFormation, Terraform, and CDK. And CDK is definitely advanced and loved by a lot of members in the community. But both serverless and Terraform, they are open source, and they actually supported by community. So meaning that they are kind of like viable, and they created with a community for community, I would say. I read a couple of articles which I highly recommend you to search on the internet, where engineers who are seasoned evangelists advocate for using combination of Terraform plus serverless approach. And this is possible and depends on the size of your project. But again, CDK is a very good at scale and very good when you infrastructure is complex and multi-layer and have a lot of nuances and details. But if you just starting, if you're a startup or your project is small, you can consider using combination of the tools or just a smaller serverless directly, because it's been developed for serverless application. So that's from my perspective. Let's switch to another question. Is it possible to configure Lambda to fast run after the while idle time without having to ping it once in a few? And I believe you already answered this question in your presentation. It's about provision concurrency, and you also gave a
Yes.
few other notes on the reducing the code, simplifying, and just remember that provision concurrency was introduced recently. Again, when I started working with Lambda, that there were no provision concurrency. Maybe you want to add anything from your end in addition to that?
No, I think that's correct. I covered it. So first, you can optimize your function to reduce the cold start, which you are responsible for. So like the initialization time and yeah, so everything that you do in initialization phase, it's your responsibility. So yeah, I mentioned different techniques how you
Yes.
can reduce this time.
Take
But from ad,
responsibility.
yes, so shared responsibility, yes, but from our responsibility. So if you do not want to hit with cold starts, then you can pre-warm these environments using provision concurrency, and it can be done like automatically based on patterns, or you can do it on schedule. So there is a way how you can pre-warm these environments if you know the patterns.
Got it. Got it. So another interesting question is about limits. So is there any possibility to extend 500 megabyte temporary storage limit?
Uh, no, but what you can do, you can use EFS, for example, for your temporary storage. So EFS, I mean, you can have any size. You just mount it and use it as a temporary storage. Create some data in EFS based on function ID or whatever.
Right, right. This is one of the mindset which we need to remember when we're working with serverless and with Lambda, that there are some limitations, and you need to share this responsibility with developers and understand that this is not just a regular web server with a just where you put all your code and it works. You need to look more granular to Lambdas, and EFS is one of the features which were long expected, where you can actually connect and either get information from EFS or drop your information on EFS and use it as a temporary storage. So consider that this is a very convenient way to do that. Also, what about Lambda layers for sharing code between Lambdas?
Yeah, so you can use Lambda layers, but it's only if you package your function as a zip. So you cannot use Lambda layers with container image, because in container image you have everything basically. But you can use Lambda layers in functions to share some common pieces of code, like logging, for example, or some performance metering if you need. So it's a way to do this code sharing.
Right, right. Totally agree with you. Another question is what the actual benefits of running Lambda on Graviton 2? Is there anything that needs to be adopted in order to switch Lambda to ARM processors?
Uh,
Very good question.
so yeah, uh, and yeah, our best answer is it depends. So if you just use your uh, uh, our runtime, so you don't use I know very specific like third-party libraries. then probably it will just work out of a box. But I don't know, test it for your payloads, do proof of concept, and check if it works. I guess this is the best suggestion, because if it works, I mean, you will get up to 35% price performance benefit. Just
Right. And with Lambda, it's all about performance, right? So you're paying for actually time and resources you spending while your code is running. And the ARM architecture gives you optimal and even more performant environment. And again, for if you're using like simple lambdas, where you can just drop your code and you using our standard wrapper, in this case you almost don't need to do anything because it's already taken care of. If you're using images, then you need to take the image based on the ARM and rebuild your Lambda image to take advantage of it. This is basically like switching between architectures. So it shouldn't be any challenges with that. So is there any way to easy cache responses from Lambda by seeing some headers? That's another question.
But I think it should not be like responsibility of Lambda. It should be responsibility of API gateway, for example, to cache the responses from underlying Lambda functions, I would say.
So recently, actually, we introduced Lambda at Edge. It's a similar concept of Lambda, but it's like with a smaller resources, and it's like for real this pre-processing of the headers. So you can look at the Lambda at Edge functionality, and this Lambda at Edge is actually suitable, a very good use case when you inspecting headers, and you can easily redirect or just process or pre-process your request. So look at the Lambda at Edge functionality.
Yeah, but Lambda at Edge, I mean, I want to mention that it's different from the Lambda functions which I'm talking about. So it shares the same name, Lambda, but it's different execution environments, different limits. So, I mean, nearly everything which I mentioned will be quite different on Lambda at Edge, because it has to be like super fast. It's different runtimes, but for this use case, as Igor said, check
Yes.
Lambda at Edge. But it has its own limitation. It's applicable in different use cases.
There is another. We have a lot of questions, and I'm keep going through them. And one of the interesting questions is which workloads are not suitable for Lambda?
So again, take a look at Lambda limitations. So for example, Lambda has a 15-minute execution time. So if you have some heavy calculations which can take more than 15 minutes, then again, Lambda is not suitable for this kind of workload. Or if you need more than 6 vCPUs or more than 10 gigabytes of memory. So again, if you need some huge compute environment, again, Lambda is not good use case. But I would say the approach should be, okay, like how can I adopt my workload that Lambda is suitable for it? Because with serverless, I mean, your area of responsibility is much smaller compared to other use cases when you, build your solution on EC2 or whatever. So just try to see if you can adopt your architecture to use Lambda, because you will benefit a lot from it.
Got it. Totally agree with you. Look at the limitations and look at what you're trying to achieve, right? So one of the things which you mentioned, but I want to tell a little bit more about is event-driven architectures. So Lambda is very good at event-driven architectures, and it easily integrates throughout other services where you can, for example, without standing up a like web server, for example, you can put event-driven architecture where you, for example, drop in file on S3, Lambda listens to it, just picks up processing file, drops it in a queue, or drops a message in a queue. It's picked up by another Lambda in the queue, and you also use step functions if you have a more complex workflows for event-driven architectures. And that's where Lambda actually playing a great role, and a like very nice Lego block which could actually easily be integrated into other services and other pieces of the workflow you're trying to build. So this is one of the great use cases. For other use cases, it's not possible to go through all of them, right? But keep in mind the nature of the serverless and of the Lambda execution. There is another question, Alexander, for you. Do Lambda somehow share database connections or shards, or is just connecting per each Lambda instance?
And I think this is what I mentioned with RDS proxies. So, but RDS proxy, it's a feature of a database. So I think it's available in Aurora, it's available in RDS MySQL and PostgreSQL. So if you are talking to database at AWS which supports RDS proxy, then Lambda can utilize it, and then you will have like pool of connections instead of each Lambda having its own connection. So you will not be throttled on database connections when you use RDS proxy.
Got it. All right. So there is another good question: how to deal with Lambda CI/CD for updates of function code, layers plus environment vars, and while managing infrastructure with Terraform. So basically, maybe in general, managing CI/CD pipeline and Lambda updates and layers and everything. Maybe if you can give a few words about it.
So I'm not expert in Terraform, but I will talk from Lambda perspective. So Lambda functions, they have versions. So when you deploy a new version of a function, you can gradually shift traffic to this version using aliases. So this is how you can test your function and test that it behaves in production as expected. And using our code build service. So if you build a CI/CD pipeline using our code services like code commit, code build, code deploy, code pipeline. So code deploy, it supports deployment of code to Lambda functions, and it supports this blue-green deployments or canary deployment patterns. So you can configure it in code deploy based on your needs. So take a look at code deploy.
Code deploy, code star services, which like suitable for serverless as well. There is another good question, and question about around security. Is there any best practices around roles and the permissions for the serverless application?
It's the same rule which applies to all other services, is to use least privilege. So when you assign execution role to your Lambda function, again, give the only required rights to this function. So if function needs to read data from S3, create a role which allows it to only to read from S3. So that's why I mentioned that you need to create single purpose Lambda functions, because when you create, multiple Lambda functions in the same bundle, then like the role that you need to assign should be the one which covers like all of them. But if you create like single purpose functions, then you can also assign these granular permissions using this least privilege principle. So there's nothing new in Lambda.
Right. Actually, this security is a job number one for us. Job number zero. It's all the services at the AWS. They are following the same concept of the least privilege, and they all of them could be fine-tuned in using our identity access management console and using policies and roles, and that's where just having those basics. If you are not very familiar with a permission model, just go and just learn it, because it is going to be across all the services. It's so important. So it should be, I believe, the one like very important like first course which should be done for all the people who start working with AWS cloud, because security it's super important with a number of such a variety of incidents across the world and different situations. It's better to be on top of the edge with that. So, and last question, it relates to CI/CD pipeline for serverless, is whether images, whether Lambda images, which is limited to 10 gigabytes, where are they stored during for CI/CD? And the answer is simple. We can store them in Elastic Container Registry in ECR for further reuse and like easy management and maybe sharing between accounts.
Yeah, exactly.
All right, so I believe that's it. Thank you, Alexander, so much for this journey to Lambda, and thank you for your answers. Thank you for the presentation. It was super helpful. Again, considering that so many new updates have been introduced to AWS Lambda, and this became not just a like little POC service, but it became like really solid foundation for many experiments and many different innovations. This is important to look deeper, and thank you so much for this presentation.
Yes, and thank you for inviting me. So I hope it was useful even for experienced developers.